jet aircraft that flies more than 500 miles an hour. Of conventional design, it is 44 feet long with a 30-foot wingspan. It was designed and built by Ryan Aeronautical Company in conjunction with General Electric, developer of the aircraft's lift-fan propulsion system. In May 1964, the XV5A began an exhaustive flight test program at Edwards Air Force Base. The plane weighs 8,080 pounds empty and, loaded with fuel ready for a mission, weighs nearly 12,000 pounds. Although the XV5A looks and performs like a high-performance jet, it also has the unique capability of taking off vertically, hovering, maneuvering while hovering, and landing like a helicopter. The Vertifan concept draws on the best features of jet engines for cruise, and fans, or rotors, within the wing for vertical and hovering flight. The power for normal cruise is all that is required to also accomplish vertical flight. In effect, VTOL capability is a bonus. Only the lift span eliminates the penalty of installing, just for vertical flight, far more power than is needed for conventional flight. The aircraft can back up, fly sideways, and perform all the maneuvers normally expected of a helicopter. XV5As have logged more than 125 flight hours in well over 300 flights. Early tests evaluated the basic capability of this fan-and-wing aircraft in both high-speed flight and helicopter-like flying, operating from concrete runways at Edwards. Though early flights proved the validity of this VTOL concept, the XV5A has recently completed a new series of demanding tests from unprepared sites that demonstrate this type aircraft can land vertically on and take off vertically from any surface that will support its weight. The wing fans operate at quite moderate RPM, creating columns of relatively cool, low-speed air which permit operation from areas unusable by most other VTOLs. The XV5A operated in the vertical mode at several rugged, bare sites in the Mojave Desert. It operated from an alfalfa field and at a simulated forward encampment on the golf course driving range at the Naval Ordnance Test Station. In investigating its capability as a rescue vehicle, the XV5A raised a 235-pound instrumented dummy while hovering over the Edwards runway, was tested in hover over water, and hovered stationary at various altitudes while a ground crewman walked up to and under the aircraft. A modified XV5A air-sea rescue plane would be capable of operating from unprepared sites or aircraft carriers as a strike escort. Like other planes in the flight, it can be refueled en route to an attack mission where it would loiter near the strike area and be available in the event of an emergency. The modified aircraft would have a passenger compartment behind the side-by-side cockpit, an access door to the compartment, and a recovery hoist extending through the open door during rescue operations would be provided. The modified XV5A is capable of descending rapidly to a hovering altitude of approximately 50 feet, facilitating the rescue of downed crewmen. Because the XV5A has both hovering and high-speed capability, it can evacuate the area at jet speed and return in minimum time to its land base or to an aircraft carrier. The outstanding efficiency of the Ryan Vertifan stems from a unique power transmission system. When normal jet thrust is diverted from the tailpipe to spin the rotor-like fans within the wing and nose, the resulting downward thrust is multiplied threefold. The fans are like multi-bladed airplane propellers, in this case accelerating the air directly downward to lift the plane vertically. Louvers resembling Venetian blinds under the wing fans are directed to move the aircraft forward, backward, and sideways. The louvers also control turns and other maneuvers performed while hovering. The stick and rudder pedals are conventional. The only additional cockpit control is a lift stick, similar to that in a helicopter for vertical control. In this concept, the same basic power output serves the entire range of flight modes, hovering to maximum speed. Power and fuel required are the same for vertical flight and hover as for conventional high-speed cruise. No other VTOL system is so efficient. The wing fans are driven by the jet thrust from two General Electric J85 turbojet engines mounted high in the fuselage. This pneumatic exhaust gas cross-coupling between horizontal flight jet engines and vertical flight wing fans eliminates complex mechanical power transmission systems. Here, the XV5A demonstrates a typical air taxi maneuver, a capability required of all Army helicopters, as it lifts off the parking ramp at the Army test activity. It takes off close to the hangars and to other aircraft and helicopters, then air taxis in formation with the Army Huey. These and similar tests prove that Vertifan aircraft can operate in a confined area in close proximity to nearby aircraft, personnel and equipment, and that fan downwash, even in confined areas, is acceptable. At the intersection of the hangar ramp and the taxi runway, both aircraft hover momentarily while waiting for tower clearance, then accelerate out over the Edwards Dry Lake bed. Following the climb out on fan power, the XV5A gains speed and altitude rapidly. At approximately 90 knots, the aircraft achieves wing lift and aerodynamic control and can be converted to jet configuration. The nose of the aircraft is brought up in a climb as the conversion is made in just 2 seconds. Significantly, there is no loss of altitude. Conversion is accomplished as the thrust is diverted from the fans to the conventional tailpipes and the wing and nose fan doors are closed. As a conventional jet, the XV5A is capable of all maneuvers expected of jet aircraft. This demonstrated capability, together with the ability of the aircraft to hover, land, and take off vertically, adapt readily to the performance requirements of a strike escort aircraft. Here, the aircraft is converted from conventional jet configuration to fan flight configuration at 2,500 feet above the terrain as Ryan's chief test pilot, Val Schaefer, begins rapid descent tests. You experience the letdown from the co-pilot's viewpoint, through the eyes of the camera mounted in the cockpit on the right side of the aircraft. It is important to note that the camera is unstabilized and is merely bolted to the aircraft. The steady ride down gives an idea of the stability of the aircraft at an airspeed of 45 knots. The descent rate is 2,500 feet per minute, approximately 3 times as rapid as that of a helicopter. The XV5A's capability to achieve the rapid descent adds to the Vertifan's adaptability as a strike escort rescue aircraft. From a loiter altitude, it could be hovering over a downed pilot almost before he could get out of his parachute, and the rapid descent would reduce the exposure time of the aircraft to ground fire. It should be noted that if the pilot raises the nose at any time during the descent, the aircraft will simply come to a hover. Final approach is made over the runway, and the plane is turned into the wind. It took 1 minute and 45 seconds to achieve the descent and touchdown from 2,500 feet. As the nose of the aircraft drops, the nose wheel will have touched the ground, and the vertical landing will be completed. Highlighting the simulated air rescue test was the pickup of an instrumented dummy as the XV5A lifted off, then hovered nearly motionless over the Edwards runway. A standard helicopter rescue hoist was mounted externally behind the nose wheel on the underside of the fuselage for this test. The 50-foot cable was attached to the 235-pound mannequin, which had instrumentation to record G-forces from a strain gauge installed in the lift cable. Temperature-sensitive paint was applied to the helmet and shoulders of the dummy to determine the effects of heat from the wing fan downwash. Temperatures experienced were less than 135 degrees. Notice the stability of the mannequin as it is raised slowly in this first test of a jet aircraft hovering to simulate a rescue. A down-pointing camera also records the stability of the XV5A in hover, as the white runway marker never appears to move. This also shows the stability of the dummy as it comes up under the aircraft, forward of the wing and wing fans. The dummy experienced little buffeting. Downwash loads on the dummy were less than 65 pounds, about what is experienced under the average helicopter. As the dummy rescue was completed, it is important to note that the hovering XV5A weighed approximately 11,500 pounds. It raised the additional weight of the dummy and cable, hovered nearly motionless, almost a hands-off operation for pilot Schaefer, on only 4,500 pounds of installed thrust. This is a dramatic portrayal of the ability of the Vertifan to multiply installed thrust threefold for vertical takeoff, landing, hovering maneuvers, and extended hover. After lowering the dummy down to the 50-foot cable length, Schaefer translated at speeds up to 30 miles per hour, with no noticeable strain on the dummy. On the next flight, Orion flight test crewman, experienced in actual rescue recoveries, walked underneath the XV5A as it hovered at several different heights to evaluate conditions that would be encountered by a man reaching for a rescue seat or sling. The crewman was dressed in standard military clothing. With the XV5A hovering at 60 feet, he walked directly under the aircraft and moved about freely. He reported that wind blast and noise were acceptable, and it would have been quite easy to climb into a rescue seat or sling. At 35 feet, the crewman experienced some pressure from the fan downwash, but walked to a position beneath the nose wheel. In tests made at 25 feet and lower, he walked to within 10 feet of the aircraft. Even this close, he reported no objectionable sensation of heat or noise. Environment and erosion tests to evaluate the ability of Vertifan aircraft to land in austere or remote, unprepared areas were carried out at various sites near Edwards. Here, the XV5A prepares to land on raw Mojave Desert. This ground camera shot, about 100 feet from the landing site, shows the dust being blown out and away from the aircraft as it makes a slow vertical descent. The downwash from the vertical lift fans pushes the rocks, dust, and debris away from the airplane, leaving it in a bowl of clear air, as this overhead camera shot reveals. At no time was there any ingestion of foreign objects into the high-mounted jet engines or into the fans, even though the area had recently been graded lightly to provide a level landing site. As in all tests at the unprepared sites, the pilot had no trouble seeing either the ground or the horizon. This was the first time a jet aircraft had landed vertically and taken off vertically from the open desert. In a further test at the same location, the landing site was covered with a 55 by 90-foot light membrane, a standard covering used in Army helicopter operations. The area was graded slightly with an edge trench around it. The membrane was then rolled out, the edges staked down, backfilled and secured to ensure that air did not get under the material. The simple-to-install membrane eliminated virtually all dust. It is felt that even light Dacron sail material would achieve the same results. After the vertical landing, the XV5A lifts off, making a rapid vertical climb. Pilot Val Schaefer described this area as covered with rocks as big as golf balls and as small as peas. The X marks the spot where the aircraft will land, a location with the worst conditions the test team could find at Edwards, one to give the aircraft and pilot the greatest challenge. As the aircraft hovers, then descends toward the site. The fan downwash pushes the rocks, big and small, along the ground, away from the aircraft. This view from the co-pilot's seat shows the dust cloud forming, but note that the pilot has no trouble maintaining visual contact with the horizon. The cockpit camera gives a good view of the ground when the nose wheel settles and the landing is complete. The camera continues to run, and as power is brought back up, the aircraft lifts off vertically, shunning the dust cloud, which rapidly disappears as the aircraft makes a climbing vertical turn. Again, there was no problem with foreign objects in fans or engines. The program continued with tests of the XV5A hovering over water to study the effects of downwash. In a further look at air-sea rescue capability, life rafts were used on the water surface. As the aircraft turns, it is hovering 70 feet above the surface. You can see a life raft below it, weighted with 200 pounds of ballast, the weight of a man, and anchored with the standard sea anchor found in life raft survival equipment. As the hovering XV5A descends, the raft is pushed out from directly under, but remains very close to the aircraft. The thrust of the wing fans makes an interesting double donut pattern on the surface of the pond, as the invisible columns of thrust that hold the aircraft in the air while hovering cause the surface of the pond to ripple. The fine mist dissipates as it rises from the surface. Observers said rescue from the sea-anchored life raft would be no problem with the aircraft hovering at 70 feet. With an okay from a nearby farmer, the austere environment tests continue with an alfalfa field as a landing site. The ground here is about 50% alfalfa stubble and 50% bare earth. The vertical landing and takeoff are accomplished without incident, as the fan downwash neatly sweeps the area of loose alfalfa clippings. As pilot Schaefer lifts vertically off the farmer's field, he turns while climbing, then adds full lift power, achieving a vertical climb rate of 2,200 feet per minute, which can be continued for thousands of feet if desired. It gives aircraft, using the Vertifan concept, the ability to quickly evacuate an area after rescuing downed airmen. It is a further measure of this VTOL's agility, maneuverability, and high-performance characteristics. In a simulated test of mobility and support of frontline encampments, the XV5A flew to the China Lake Ordnance Test Station and landed in a simulated forward Army encampment area set up on the golf course driving range. Tents, vehicles, oil drums, support personnel, and a Navy helicopter were located near the landing site. This view of the landing from a camera mounted on the tail of the aircraft records the ease with which the landing was made. As the aircraft lands within 60 feet of the nearest tent, little disturbance to tents, personnel, or equipment is noted. Observers were hard-pressed to identify the exact landing location on the golf course turf. No burn marks were found, even though the XV5A remained on the ground with its lift fans running for an extended period at this site. Following a vertical takeoff, the XV5A converted from fan flight configuration to conventional jet configuration and made a high-speed jet return to Edwards. On a later flight, the XV5A again investigated the ability of the Vertifan in high-performance letdowns after converting from jets to fans for the steep descent to a vertical landing. This differed from the earlier test, as the pilot lowers the nose and makes a straight-in approach to his landing site. Here, in the steep descent, he is again indicating 45 knot speed and developing a 2,500 foot per minute descent rate. In this dramatic demonstration of mobility, he levels off over the taxi runway, makes a right turn, locates his landing spot, takes note of the wind direction provided by the flagman, points the aircraft into the wind, and makes a vertical landing. A similar approach technique can be used for landing on a platform aboard ship or on an aircraft carrier deck, either stationary or while underway in fleet operations. Though not part of the austere environmental tests, the XV5A was compared to an Army helicopter in so-called agility tests. They proved that the XV5A, weighing 11,500 pounds, performed much like one of the Army's most agile helicopters. Flying a closed course in the hover mode, following vertical takeoff, each aircraft in turn was to fly a leg, stop, turn in place, fly another leg, stop, turn in place, back up, fly sideways, etc. Val Schaefer in the XV5A completed the 3.2-mile agility course in 5 minutes 30 seconds, using attitude control rather than fan louver control. He then stepped from the XV5A, got into the Army helicopter, and flew the same course in just under 4 minutes. A measure of the agility of the XV5A was its ability to fly backwards, paced by a car at speeds up to 25 miles per hour. Sideways, it flew at 35 miles per hour. As the XV5A begins its third year of flight tests at Edwards, the austere environment tests, simulated rescue and forward area support tests, represent the most comprehensive analysis short of operational testing. From these tests may come the world's first high-performance strike escort aircraft, a modified XV5A combining jet aircraft speed and helicopter mobility.